Hi, I'm Emma McGrattan and welcome to my home. We're on the beautiful south shore of Long Island, New York. So what I'm here to talk to you about today is Actian Avalanche and how Actian can make a claim that we can cut your snowflake bill in half. I think to really appreciate what we can deliver with Actian Avalanche in terms of price performance, it helps to understand the underlying technology. So Actian Avalanche was initially designed to deliver superlative performance on commodity resources. And at the time we were designed, it was for an on-premise deployment where these resources were in very scarce supply. If we look at CPU, RAM, and disk, we'll show you some of the clever things that we did to maximize the efficiency in our use of these resources. So let's start with CPU. We used a capability called Vectorization. To really appreciate vectorization, I want to take a step back and explain to you the opposite of vectorization, which is scalar processing. Let's assume a really simplistic use case here where I'm the branch manager in a bank and I'm coming up with the total for all of my customer accounts by adding together their checking account balance with their savings account balance to give their total balance. Really simple example, right? But what I need to do is to go record at a time through each of my customers, pulling out these two values, summing them together to get the result all the way till I reach the end of the table. Now, very inefficient use of resources in executing that query. Let's look at how this would work in a vectorized world. So if you haven't heard of a vector, you can think of it as an array of values. Typically that array has about 1,000 values per vector. It really depends upon the width of the values, but let's assume 1,000. It makes the math very simple. So now we have a vector that's been populated with customer checking account balances, right? So we've got 1,000 of these occupying our first vector. Then we've got our savings account balances in this second vector. Now we're going to perform that same addition on these, and in a single cycle we get back the results for the addition of these 1,000 values to 1,000 values, and we get 1,000 values back in our result. It's incredibly efficient, right? By the time we get the first 1,000 customer balances back, these guys are about this point in their process. So that just shows you the order of magnitude difference in terms of the performance that we can deliver with Actian Avalanche. This capability you may hear referred to as SIMD, which stands for single instruction, in this case addition, multiple data, these arrays of values that we're dealing with. Now the next thing that Actian Avalanche did that's clever in both the CPU and in memory is that we recognize the fact that today's CPUs have about 8 meg of level 1 and level 2 cache on the chip itself, right? It used to be when the likes of Oracle Exadata were designed that high-end servers had about 8 megs of cache in them. So really important to us to recognize the fact that that memory was there and to use it as execution memory for when we're running queries. So if we look at the graph, what we have on the y-axis here is the time or the number of cycles it takes to process data from disk, from memory, and from CPU. And on the x-axis, we have the amount of data that we can process in a second. So you can't get better than this. Now we still use RAM for many of the caches that are in the database, and we've got some very clever eviction algorithms there. But utilizing the chip cache for execution memory was very clever and something that helps with the performance characteristics that we deliver. Now the next thing that we've done with the CPU is recognize the fact that today's servers have a number of sockets on them. Each of those sockets has a lot of cores available to us. And what we wanted to do with Actian Avalanche was maximize our utilization of all of those cores. To do that, there's two things that we look at. The first is we designed Avalanche for satisfying the queries of large numbers of concurrent users. We want to work in those large organizations where they've equipped everybody with a copy of a business decision-making tool. It might be Tableau, Power BI, MicroStrategy, Looker, Qlik, doesn't matter to us. They choose the tool that works for their organization. But we're going to be able to satisfy large numbers of users all working in parallel. And for each of the queries that we're getting from those users, we want to be able to split those queries into chunks so that we can execute those chunks in parallel. So we get that extra level of parallelization, because ultimately what we want to do is to make sure that every core that you're paying for in your infrastructure is being kept as busy as possible, satisfying your users' needs. So another reason why we're as fast as we are, and we have as a design point satisfying large numbers of users running concurrently against the system. Now the next thing with Actian Avalanche comes to efficient utilization of disk, and that is the fact that we're a pure column store. So in traditional databases, when you're dealing with row-based processing, if we were satisfying a simple query like get me a list of account numbers where the balance is over $1,000 and the zip code is 11749. Really simple query, but if I'm satisfying that in a technology like Oracle, and I go to read this line here, this row that qualifies, I'm actually going to have to read in data like the first name, last name, the gender, the street name, the suburb. None of it applies to the query that I'm running, and it's taking up space in my cache, right? We call it cache pollution. So row-based doesn't work well for analytics type queries. What works well for analytics type queries is if you were to treat the data as a series of columns instead of a series of rows. So what we do now is we're reading just those columns that are required to satisfy this particular query. It's much more efficient, right? You're just reading the data that applies. You're not polluting your cache with extraneous data that isn't required to solve your query. Now, each column that we write to disk is stored as a series of files on disk, right? And each of those files is made up of a set of blocks. And as we're writing those blocks out to disk, we keep track of the minimum and the maximum value that's written into each of those blocks, and we store that as an automatic storage index. We refer to it simply as a min-max index because it's keeping track of the minimum and maximum value in each block within each file. Now what that allows us to do is if we're doing an exact lookup or we're looking at range queries, and we know which of the blocks that are going to satisfy the queries and which of the blocks that we can completely ignore. So for sorted data, this works really well in minimizing the amount of I/O that's required to satisfy a query. These min-max indexes live in memory, so they're very fast to look up. If you have very wide columns, very wide table with a large number of columns, some of which are not referenced in solving queries, you can switch off the creation of these indexes on those columns. Designed for simplicity, we'll automatically create these indexes, so we typically recommend that you don't create any indexes at all. You create your schema, we'll create these indexes, you start running your queries, and if we find something's not optimized, then we'll look to create secondary indexes. Now, most databases compress data to store it on disk, and there's two primary reasons to do that. One is it reduces the footprint on disk, right? So it's more efficient to write to disk and to read it because you're dealing with less data. And the second reason is it moves to the system much more efficiently when it's smaller, right? So those two reasons really are the motivator for compressing data on disk. Now, in Actian Avalanche, when we're dealing with column-based data that we're reading, it really helps because all of the data within a column is going to be of the same type, right? So when we're dealing here with our count numbers, we know they're all going to be integers. We're not going to encounter a date, for instance, in this column. Similarly with balance, right? These are all going to be floats. Gender is going to have very few values. So we can identify very quickly which is the best compression algorithm to use for each of the columns that we're writing to the database. So that's something that we decide upon based upon the efficiency of decompression of the data into the CPU cache. In a more traditional row-based system, and we've got a mix of different types of data, it's very hard to choose an algorithm that's going to work well for all of them. So you typically wind up with a lowest common denominator there. So they're not very efficient in terms of compression. So when people ask me what makes Avalanche as fast as it is, it really is all of these things working together that deliver upon the performance characteristics that Avalanche can provide. So it's the vectorized processing together with using the CPU cache as execution memory, using this multi-core parallelism, right? These are all CPU related benefits that we can provide. And then over here on the storage side, it's a pure column store. So you're only reading the columns that apply in solving your query. And we've got these storage indexes to minimize the amount of I/O that needs to be done to solve a query. And we've got smart compression, and that will typically give you about a 5-to-1 compression ratio. So if you had 10 terabytes of data, it'd be about 2 terabytes of data that you'll be paying for in Actian Avalanche. So together, these all help us deliver the performance characteristics that we can, both on-premise and in the cloud. So I hope I've convinced you to take the next step in looking at Actian Avalanche. And what I would love to see you do is to sign up on Actian.com for our $500 free trial of Actian Avalanche. Because the only way of convincing you that this is right for your business is for you to load your data, run your queries, and see for yourself what Actian Avalanche can do. Then what you'll have to do is to decide, how does the performance and the price point that we can deliver that performance at change your business?